Good morning, everyone. I'm Uma Maheshwari, Assistant Professor, Department of Electronics and Communication Engineering. In this video lecture series, I'm going to explain about what is meant by entropy and the source coding theorem. Entropy is nothing but it can be defined as a measure of the average information content per source symbol. Then, further of the information theory provided a formula for this as H, which is equal to minus summation of Pi log B Pi, where Pi is the probability of the occurrence of character number I from a given stream of characters, and B is the base of the algorithm used. Hence, this is also called as a Shannon's entropy. The amount of uncertainty remaining above the channel input after observing the channel output is called as a conditional entropy. It is denoted by H of x by y. Average information rate and entropy. Here, entropy information theory is a mathematical approach to the study of coding of information along with the quantification, storage, and communication of information. Then this information is the source of a communication system, whether it is analog or a digital. It might be anything. So Pi is nothing but a probability of the occurrence of a character number, where I is from a given stream of characters and B is the base of the algorithm which is used. This is called as a Shannon's entropy. Here information rate is defined as the formula for measuring the amount of information received by multiplying the amount of information content for each character by the number of characters that are being transmitted every second. This is nothing but the source coding theorem. Here it is produced by the discrete memoryless source which has to be efficiently represented, and for this there are code words which represent these code words. According to the Morse code which we use in telegraphy, the alphabets are denoted by marks and spaces. So discrete memoryless source where the source is given to the source encoder and will get a binary sequence over there. Then the main purpose of source coding is to improve the efficiency of the communication system. Source coding or source encoding is the process by which the efficient representation of data generated by the discrete source is achieved. The device which performs source coding or source encoding is called the source encoder, where here the set of messages will be represented by M1 up to Mn into a new set of encoded messages C1, C2 up to Cn in such a way that the transformation is 1 to 1. That is, for each message there is only one encoded message. So here it will be having a without encoder to decoder and a with encoder to decoder. Without encoder to decoder will be having source, channel, receiver, and their source, encoder, channel, decoder, and the receiver. The messages are first encoded by the encoder and then transmitted via channel. Efficient source encoder can be designed which uses the statistical properties of the source. At the receiving end, the received messages are first decoded in the decoder and then the original messages are required. In the generation of a source code by assigning short code words to frequent source symbols and long code words to rare source symbols. This type of source is called as a variable length code. This is nothing but the representation of the source coding algorithm. Here we define the average code word length L bar of the source coder as L bar, which is equal to PKLK. Then the coding efficiency can be defined as eta, which is equal to L minimum by L bar. L minimum is nothing but a minimum value of length. L bar is nothing but the code word length. In simpler words, the code word is always greater than or equal to the source code, which means the symbol in the code word are greater than or equal to the alphabets in the source code. Hence, L minimum, which is equal to H of del, the efficiency of the source encoder in terms of entropy may be written as efficiency, which is equal to H of del by L bar. This source coding theorem is called as a noiseless coding theorem, and as it is established by the error-free encoding. It is also called as a Shannon's first theorem, where source coding we call it as a Shannon's first theorem. That is stated as a given discrete memoryless source of h of s, the average code word length L bar for any distortionless source encoding is bounded as L bar, which is less than or equal to h of s. Then code redundancy. It is defined as redundancy gamma, which is equal to 1 minus code efficiency, where code efficiency is represented as eta. So the assessment is what is meant by entropy, define information rate, and what is meant by code redundancy.